the beginning through all of its evolutionary stages to the modern form. It is perhaps one of the most complete and well-documented chapters of paleontological history. Fossil finds provide us not only with detailed information about the horse itself, but also with valuable insights into the migration of herds and even evidence for the speculation about the climatic conditions that could have instigated their migratory behavior. Now, geologists believe that the first horses appeared on Earth about 60 million years ago, as compared with only 2 million years ago for the appearance of human beings. There's evidence of early horses on both the American and European continents, but it's been documented that almost 12 million years ago, at the beginning of the Pliocene age, a horse about midway through its evolutionary development crossed a land bridge where the Bering Strait's now located. It traveled from Alaska into the grasslands of Asia and all the way to Europe. So this early horse was a hipparion, about the size of a modern-day pony, with 3 toes and specialized cheek teeth for grazing. In Europe, the hipparion encountered another less advanced horse called the Anchithares, which had previously invaded Europe by the same route, probably during the Miocene period. Less developed and smaller than the hipparion, the Anchithares was eventually completely replaced by it. By the end of the Pleistocene age, both the Anchithares and the hipparion had become extinct in North America, where they originated, as fossil evidence clearly demonstrates. In Europe, they evolved into the larger and stronger animal that's very similar to the horse as we know it today. For many years, this horse was probably hunted for food by early tribes of human beings. Then the qualities of the horse that would have made it a good servant were recognized, mainly its strength and speed. It was time for the horse to be tamed, used as a draft animal at the dawning of agriculture, and then ridden as the need for transportation increased. It was the descendant of this domesticated horse that was brought back across the ocean to the Americas by European colonists. The development of the horse has been recorded from the beginning through all of its evolutionary stages to the modern form. It is perhaps one of the most complete and well-documented chapters of paleontological history.
Okay then, let's talk about human memory, which was formerly believed to be rather inefficient as compared with, for example, computers. But we're finding that we probably have a much more sophisticated mechanism than we'd originally assumed. Researchers approaching the problem from a variety of points of view have all concluded that there's a great deal more stored in our minds than has been generally supposed. Here's what I mean. Dr. Wilder Penfield, a Canadian neurosurgeon, proved that by stimulating their brains electrically, he could elicit the total recall of complex events in his subjects' lives. Even dreams and other minor events supposedly forgotten for many years suddenly emerged in detail. The memory trace is the term for whatever forms the internal representation of the specific information about an event stored in the memory. So the trace is probably made by structural changes in the brain. But the problem is that the memory trace isn't really subject to direct observation because it's more a theoretical construct that we use to speculate about how information presented at a particular time can cause performance at a later time. So most theories include the strength of the memory trace as a variable in the degree of learning, retention, and retrieval possible for a memory. One theory is that the fantastic capacity for storage in the brain is the result of an almost unlimited combination of interconnections between brain cells stimulated by patterns of activity, and repeated references to the same information supports recall. Or to say that another way, improved performance is the result of strengthening the chemical bonds in the memory. Now here's the interesting part. Psychologists generally divide memory into at least 2 types, short-term memory and long-term memory, which combine to form what we call working memory. Short-term memory contains what we're actively focusing on at any particular time, but items aren't retained longer than 20 or 30 seconds without verbal rehearsal. We use short-term memory when we look up a telephone number and repeat it to ourselves until we can place the call. In contrast, long-term memory can store facts, concepts, and experiences after we stop thinking about them. All conscious processing of information, as in problem solving, for example, involves both short-term and long-term memory. As we repeat, rehearse, and recycle information, the memory trace is strengthened, allowing that information to move from short-term memory to long-term memory.